Welcome to the deep dive. Today, we're diving into something called Easy Java Simulations.
Okay.
It's this free open source tool, and you can use it to build interactive physics simulations.
Hmm.
You might be thinking, okay, so cool graphics, but so what? What's the big deal?
Right.
Well, that's what we're here to find out.
Okay.
We've got this fascinating source. It's a web page from 2013 all about a workshop.
Okay.
And this workshop was held in Singapore to train teachers
Interesting.
to use this tool to design their own simulations.
I see.
So imagine a world where physics education is less about like memorizing formulas
Yeah.
and more about actually like experimenting and seeing those concepts come to life.
That would be cool.
Right.
Yeah, and what's really interesting is that this workshop was already happening back in 2013.
Yeah.
Which, tells us that Singapore was already recognizing the power of computer models in education way back then.
Absolutely. Now, before we go too far, let's break down what Easy Java Simulations, or EJS, actually is.
Yeah, good idea.
What is it?
Well, EJS is a software tool, and it was created by Francisco Squembre.
Okay.
It allows anyone, even people with limited coding experience,
Mm-hmm.
to build and customize interactive simulations for science education.
Okay.
And the fact that it's open source is really key here.
Oh, why is that?
Well, because it means that teachers and students can adapt existing simulations or even create new ones
Oh, wow.
tailored to their specific needs.
That's amazing.
Yeah, so, this creates a much more collaborative and dynamic learning environment than just using traditional textbooks.
Right, I can see that. So this workshop itself, it was held at the Academy of Singapore Teachers,
Okay.
and it was led by Loo Kang, Wee Lee, Tat Leong, and Lye Sze Yee.
Kishy names.
Their goal was to empower these teachers to design simulations for concepts like falling objects, spring mass systems, and even to publish their own simulations for others to use.
The workshop organizers were clearly big believers in active learning and inquiry-based education.
Yeah, it seems like it.
They argued that computer models provide a much more engaging and effective way to learn physics than just, the traditional methods.
Yeah, I can definitely see that. I remember struggling with physics in school because it felt so abstract.
Right.
Like, I wish I'd had access to simulations like these back then. It would have made everything so much clearer.
It makes sense, when you think about how our brains work.
Yeah.
We're much more likely to remember and understand something if we've actively interacted with it.
Yeah, for sure.
And simulations allow you to visualize abstract concepts, experiment with different variables, and see the results in real time. It's like having a virtual physics lab
Oh, wow.
right at your fingertips.
I love that. Speaking of research, the workshop organizers actually cited a ton of studies to support their approach.
Oh, wow.
There was one study that really caught my eye.
Right.
It found that students using simulations actually retained knowledge better than those using traditional lab equipment.
Interesting.
Isn't that fascinating?
It really is. It's a powerful testament to the effectiveness of hands-on learning.
Yeah.
And when you combine that with the collaborative nature of EJS, you start to see how this tool could revolutionize the way physics is taught and learned.
That's a great point. But let's not just talk about theory. What did the students who actually used these simulations have to say about it?
Well, Loo Kang Wee, one of the workshop leaders, gathered feedback from students in 2012,
Okay.
and the responses were overwhelmingly positive.
Really?
Oh, yeah. They loved how engaging and fun the simulations were, and many felt it helped them understand the concepts much better than traditional lectures or textbooks.
That's awesome. Did any specific comments come to mind?
Well, one student said, and I quote, "This lab lets me figure out the concepts rather than just listening and believing what is taught without understanding."
Wow.
It seems they were really able to grasp the material in a deeper way.
That's incredible. It sounds like the simulations were empowering students to take control of their own learning.
Absolutely. Another student mentioned that these types of lessons, and I quote, "force us to think critically." It also gives us confidence and a sense of accomplishment when the conclusions we arrive at are correct.
Wow.
You can really sense that feeling of ownership over their learning.
What a powerful testament to the impact of these simulations. So we've talked about what EJS is, how this Singaporean workshop utilized it, and the positive impact it had on student learning. But what about the simulations themselves? What did they actually look like?
That's a great question, and that's exactly what we'll dive into next. Let's take a closer look at the specific simulations that were created and shared in this workshop and explore how they brought those physics concepts to life.
So we've established that these easy Java simulations were a big hit with the teachers and students in Singapore, but I'm really curious to know what these simulations actually looked like in practice. What were the teachers building?
Well, the web page highlights a couple of examples that really showcase the versatility of EJS.
Okay.
One simulation focused on falling objects, a classic physics concept
Oh, yeah.
that you're probably familiar with.
Yeah, I remember learning about gravity and acceleration, but I have to admit, it would have been so much cooler to actually see those concepts in action instead of just reading about them in a textbook.
Exactly, and that's what EJS allows you to do.
How so?
Like, imagine a virtual ball on your computer screen.
Okay, yeah.
With this simulation, you could control variables, like its initial height, its mass, and even air resistance.
Wow.
Then with a click of a button, you could release the ball and watch how it falls.
So instead of just memorizing a formula, you could actually experiment and see how changing those variables affects the ball's motion. That's a much more engaging way to learn.
Absolutely.
Yeah.
You could observe firsthand how gravity affects the ball's acceleration.
Uh-huh.
You could test whether heavier objects fall faster.
Do they?
Spoiler alert, they don't.
Oh, okay.
And by adjusting air resistance, you could see how that force affects the ball's trajectory.
Wow, that's amazing. It's like having a virtual wind tunnel right on your computer. The webpage also mentions simulations for spring mass systems. What could students learn from those?
Well, spring mass systems are all about oscillations,
Okay.
which are fundamental to many areas of physics.
Right.
With EJS, students could create a virtual spring, attach a mass to it, and set it in motion.
Okay.
They could then tweak variables like the spring's stiffness or the amount of mass and observe how those changes affect the period and frequency of the oscillations.
It sounds like these simulations really provide a powerful way for students to explore those concepts and make connections that might have been harder to grasp with traditional teaching methods. It's not just about creating these simulations, though, right? Right. The workshop also emphasized the importance of sharing and collaborating.
Yeah, definitely. The facilitators encouraged a true community-based approach to learning with EJS. They pointed teachers to resources like online libraries, the open source physics website, and the NTNU Java Virtual Lab.
So they didn't have to start from scratch.
Exactly. These platforms offer a vast collection of pre-made simulations that teachers can use and adapt for their own classrooms.
That's fantastic. It's like having a global library of physics experiments right at your fingertips. It takes a lot of work off the teacher's plate, but it also gives them a starting point to customize and make it their own.
Exactly. And the workshop also encouraged teachers to contribute to this library by publishing their own simulations.
Oh, that's cool.
Yeah. This open source approach fosters a collaborative environment where educators can learn from each other and continuously improve the available resources.
I like that.
Yeah, this constant evolution and refinement is another benefit of EJS that traditional textbooks simply can't offer.
It really highlights the power of community and shared knowledge in education. So we've talked about how the simulations worked and how the open source nature of EJS fosters collaboration. But I'm curious, what insights did the workshop organizers glean from the student feedback? We touched on this earlier, but I'd love to delve a bit deeper into what the students themselves had to say.
Well, Loo Kang Wee's 2012 paper, which collected feedback from students who used these simulations, offers some valuable insights.
Okay.
As we mentioned, students overwhelmingly praised the simulations for making learning more engaging, fun, and effective. But beyond that, many of them highlighted the simulation's ability to help them visualize and understand abstract concepts, which is often a major hurdle in physics.
I can definitely relate to that. Some of those physics concepts can be really tough to wrap your head around if you're just reading about them in a textbook.
Absolutely. And what's even more impressive is that the students consistently emphasized the sense of empowerment they felt while using the simulations.
Empowerment, what do you mean by that?
Many students described feeling more confident in their ability to learn and understand physics. They appreciated how the simulations allowed them to explore and experiment independently, giving them a sense of ownership over their learning.
That makes sense. When you feel like you're actively participating in the learning process, it becomes much more motivating and rewarding. It's no longer just about memorizing facts. It's about discovering and understanding for yourself.
Precisely. The simulations offer a context for learning that goes beyond just memorizing formulas. They help students develop a deeper understanding of the concepts and see how they apply to the real world.
It sounds like EJS really has the potential to transform physics education from a passive experience to an active and engaging one. But were there any challenges or limitations that the workshop uncovered? After all, no tool is perfect.
You're right, every tool has its limitations. And the workshop did identify some areas for improvement, both from the facilitator's perspective and the student feedback.
Such as?
Well, one key challenge was ensuring the simulations were well-designed and truly effective as learning tools.
It's fascinating to think that even with a tool as powerful as easy Java simulations, there are still challenges in designing truly effective learning experiences. What were some of the issues they uncovered?
Well, one of the big takeaways was that, simply creating a visually appealing simulation isn't enough.
Yeah, I can see that.
To be truly effective, these simulations need to be carefully planned and designed with specific learning objectives in mind.
Right.
They need to encourage active engagement and critical thinking, not just passive observation.
So it's not just about throwing some cool graphics and animations together. It's about creating a purposeful learning experience.
Exactly.
Did the workshop offer any solutions for this design challenge?
Well, they really emphasize the importance of incorporating strong inquiry-based activities
Oh, right.
alongside the simulations.
I see.
These activities act as a guide for students, helping them make connections, ask meaningful questions, and analyze what they're observing in the simulation. It's like providing them with a roadmap for exploration and discovery.
That makes a lot of sense. You need to give students the tools and guidance to think critically, not just watch things happen on a screen. Were there other challenges they encountered?
Yeah, another challenge they highlighted was the technical aspect.
Okay.
While EJS is designed to be user-friendly, there's still a learning curve involved for teachers.
Right.
They need to be comfortable navigating the software's interface and features to effectively create and modify simulations.
So even with a user-friendly tool, there's still a need for proper training and support to help teachers fully utilize its potential. This really highlights the value of professional development opportunities like the workshop itself to equip teachers with the necessary skills.
Absolutely. And the workshop also stressed the importance of ongoing support and collaboration. It's not enough to just give teachers the tools and then leave them to figure it out on their own.
Right.
They need access to a community where they can share resources, troubleshoot problems, and learn from each other's experiences.
Yeah.
It's like building a network of support for educators to constantly learn and improve their practice.
That's such a crucial point. Continuous learning and collaboration are essential in any field, especially in education, where technology is constantly evolving. This brings us to another interesting point. This workshop took place back in 2013. How do you think the field of educational simulations has evolved since then? What exciting developments have we seen?
Oh, the progress in the last decade has been remarkable.
Really?
Oh, yeah. One of the biggest changes has been the shift towards web-based platforms.
Here.
Remember, back in 2013, you often needed to install specific software to run these simulations.
Oh, yeah.
Now, thanks to the internet, you can access simulations from virtually any device with a web browser.
That's a game changer in terms of accessibility. It opens up a world of possibilities for students and teachers all over the globe. What other advancements have you noticed?
Well, we've also seen incredible advancements in the simulations themselves.
Well, like what?
They become more sophisticated, more interactive, and frankly, more fun. Remember that student who suggested creating a game-like simulation? Well, that idea has really taken off.
Cool.
We now have a whole range of educational games and gamified learning platforms that incorporate physics concepts in engaging and interactive ways.
Gamification seems to be everywhere these days, and for good reason. It taps into our natural desire for challenge, competition, and reward. It can make learning feel less like a chore and more like an adventure.
Exactly. Imagine a physics simulation where you're not just passively observing a falling object, but controlling a character who needs to use physics principles to solve puzzles and navigate obstacles.
Oh, wow.
It adds a whole new level of engagement and excitement to the learning process. It's about making learning both effective and enjoyable.
That sounds amazing. I'm also thinking about the rise of virtual reality and augmented reality. Those technologies seem tailor-made for educational simulations.
You're absolutely right. VR and AR are taking educational simulations to a whole new level. Imagine putting on a VR headset and stepping inside a virtual world where you can interact with physics concepts in a truly three-dimensional space. You could build circuits, conduct experiments, and even explore the inner workings of the human body in ways that were never before possible.
It's like having a science fiction holodeck, right, in your classroom. But with all these incredible advancements, are there any challenges that still need to be addressed?
Despite all the progress, there are still some important challenges that need our attention.
Like what?
But one of the biggest is ensuring that these simulations are pedagogically sound.
Okay.
It's not enough to just create a flashy game or a cool VR experience. We need to make sure that these tools are actually promoting deep understanding and meaningful learning. We need to be wary of edutainment that prioritizes entertainment value over educational value.
So it's about finding that balance between engagement and effective instruction. It's about designing tools that are both fun and educational. What other challenges come to mind?
Another challenge is the need for ongoing teacher training and support. As these technologies continue to evolve at a rapid pace, teachers need access to professional development opportunities that can help them stay up to date and effectively integrate these tools into their teaching. It's about empowering teachers to be not just consumers of technology, but creators and innovators who can adapt and shape these tools to meet the unique needs of their students.
That's a critical point. We need
Yeah.
to invest in our educators and give them the resources they need to leverage these powerful technologies effectively. Are there any other pressing concerns in this field?
Well, finally, we can't ignore the issue of equity. Access to these cutting-edge technologies is not equal across all schools and communities.
Right.
We need to work towards a future where all students, regardless of their background or socioeconomic status, have the opportunity to benefit from the transformative power of educational simulations.
That's a crucial point. Closing the digital divide and ensuring equitable access to these resources should be a top priority. It's about leveling the playing field and giving every student the opportunity to succeed.
Exactly. We've come a long way since that workshop in Singapore, but there's still work to be done. The potential of educational simulations is immense, but realizing that potential requires a continued commitment to innovation, collaboration, and equity. We need to continue to explore the possibilities, push the boundaries of what's possible, and work together to ensure that all students have the opportunity to benefit from these powerful tools.
That's a powerful message to end on. This deep dive into easy Java simulations has been a fascinating journey. We've explored the origins of this innovative tool, its impact on students and teachers, and its incredible potential to shape the future of education. What began as a workshop in Singapore has sparked a global movement to make learning more engaging, interactive, and meaningful.
As we conclude our exploration, I encourage you to think about how these simulations and the ideas behind them might impact your own learning or teaching experiences. How can we harness the power of technology to create more engaging and effective learning environments for everyone?
That's a great question for all of us to ponder. Thank you for joining us on this deep dive into the world of easy Java simulations. Until next time, stay curious,